Community, meet Holly Cummins, Senior Principal Software Engineer at Red Hat and Java Champion. Holly, are you here? Oh,
Hello,
hi,
I
Holly.
am.
I don't know, have you seen our previous speaker? But for each of you, we provide a small, Copilot avatars, as I mentioned.
Ah,
Yeah, and it was based on your answers.
yay.
This is, they will help you during your presentation, actually, and will live at our cloud, Java cloud. So, can you tell us who is this? Or who is it, she, he? I don't know. Just can you tell a couple of words about this person?
Yeah, I'm really intrigued. So I think I love octopuses. They're very different from us, but much more intelligent than you would assume. And they just have 8 legs and they're just fun. Um, and I really love cheese as well. So octopuses don't traditionally eat cheese, but in the world of imagination, octopuses can eat cheese while sitting on a cloud.
And what is the name? Let's give a name to this chapter.
Oh, naming is the hardest problem in computer science. You can't ask me to to name something.
Let's imagine that this is a class. A class. We have a properties. Yeah, it's octopus, cheese, bee, as I see in cloud. How we can name such a class?
Oh, see, if it's a class, then we can be really literal, right? So then we can just call it octopus, or we can call it cheese-eating octopus.
Cheese and
Or we could have
okay,
octopus and then the
okay.
subclass is cheese-eating octopus.
It's definitely
I'm
better
completely
than foobar.
yeah.
Okay, is he good at JavaScript? How do you think?
I'm not sure anybody's really good at JavaScript, to be honest. So I think we can assume that the octopus is also not very good at JavaScript.
Okay, and what about Quarkus?
Well, everybody's good at Quarkus. Actually, I will go back to an
Okay.
interesting thing about octopuses is that they only live for a couple of years, so they're very intelligent, but they don't get that intelligence really through sort of years and years of experience like humans do. They just learn much more quickly than us, and the JavaScript ecosystem changes so quickly that actually that's kind of ideal for something like an octopus where you have that really rapid cadence, and we're seeing that shift in Java now as well. So Java is evolving much more rapidly, and I think things like Quarkus are sort of part of that evolution where we're really becoming much more suitable for the cloud. So I think we have to assume that our cloud octopus is going to be good at Quarkus.
Okay, and what is his superpower, as you think? Superpower of this octopus. Let's give.
Oh, well, I mean, I think if you have 8 arms, your superpower has to be multitasking.
That's great. That's great. Okay, so Holling and his octopus will show us why Quarkus should be your next tech stack. Feel free to ask Holly and her octopus about everything in the Slido. Holly, I hand you on your virtual microphone.
Thank you. I feel really disappointed now that I haven't included a single octopus in my slides, but we'll see what we can do without octopuses. I noticed there was a little bee in the background of the picture as well, and I'm always very jealous of Liz Rice because she gets to include lots of bees on her slides because she works for eBPF and she has her cuddly bee. And with Quarkus, the only mascot we have really is the sort of the rock and roll guitar, which is pretty cool, but it's not a bee or an octopus. But despite that, I think there's a lot to recommend Quarkus. So really, I'm Holly Cummins. I work for Red Hat. I'm a senior principal engineer helping to build Quarkus. So I want to share just a little bit about some of the technical decisions that the Quarkus team have made that I think make it a very modern runtime and also quite an interesting runtime. And sort of to give some context to what these decisions are and why they're interesting, it's kind of useful to go back in time to kind of how computers used to be when I started my career. Although I should mention I've been in tech for a while. I haven't been in tech for this long. So this is the difference engine, 1832, never actually built, before my time. But certainly by 2005, I'd been working in tech for a few years, and it was a really different landscape to how it is now. Everything was on-prem. There was no such thing as the cloud. Everything ran on dedicated hardware, and processes were really long-lived. So often a Java server would stay up for 6 months. And even by 2015, which isn't that long ago, the landscape had shifted a bit, but only a bit. So I got in trouble in 2015 because I wrote a blog. I was working on WebSphere Liberty at the time, which then became Open Liberty. And we were so excited by what we'd done with Liberty. And it started at the time really fast. And the developer experience at the time, was really great compared to what came before. And I wrote this blog saying that it used to be that if you just wanted to try out your application locally, just get your application onto the app server, you had enough time. And in fact, you kind of had to go make a cup of tea because it took so long to do it. And with Liberty, you didn't need to make a cup of tea. But I got in trouble because apparently it wasn't such a good thing to be, comparing the new product to the old product in quite such an unflattering way. And that trend that we were seeing in 2015 of things getting smaller and lighter and faster has really just completely picked up speed. So in 2022, I started working on Quarkus, and I'll come back to it, but of course we all know it's so fast and so light. But let's pause for a minute and think, well, why is this happening? Why is there this trend in our industry for these things, runtimes, to become so much lighter? And I think a lot of it has to do with the shift to microservices. And so in 2011, our industry started talking about microservices. But what really, really enabled microservices to take off and made them such a dominant architecture was what happened in 2013. Because in 2013, we got containers, and they changed almost everything. Because the thing about containers is you almost never have just one container. They're so easy to start that you want to have all of the containers. And so this was a really natural fit for microservices. But what we were seeing with Java was we had this shift to microservices, we had this shift to the cloud, we had everything running in containers. But our Java applications, they were maybe running in a container. They were maybe running on the cloud, but they weren't really cloud native in any meaningful way. And they were really a lot more like the old Java than the new world that we were living in. So Java just didn't really behave like a runtime that was designed for the cloud. Because if you compare it to something like Go, if you have a virtual machine or a physical machine on the cloud, and then you have your container platform, you can fit a lot of Go containers into that single machine. If you're using JavaScript with your Octopus, you can fit a lot of Node.js containers in. If you're using Java, each application has quite a big heap, and the application itself takes quite a lot of memory, and you can only fit a few of these things onto your machine. And this is a problem in the cloud, but it's also a problem even for us locally, because we've gone towards this microservices architecture, which assumes that we can have many, many instances of Java. And actually, We couldn't. A little while ago, Red Hat Consulting got an email from someone, and so they were the CTO of a fintech startup, and it was doing microservices, of course. And so they wanted to bring up their application, being the CTO, but it was a Java application, and so they would try and bring up the microservices in the Java stack. And they were the CTO, so they had, this brand new Apple laptop, and it was like top of the line. It had 64 gig of RAM, and it had an M1 chip, and this thing just couldn't actually bring up the application because the application, once you spread that application across many microservices, it was too bloated. Nothing could run it unless you also had a lot of hardware, which isn't necessarily what we want. And how we run our applications in the cloud is really different as well. So the first thing is that there's more of them because we have microservices, but we also tend to bring applications up and down really often in the cloud. Applications in the cloud should be ephemeral. And so it's a little bit like a light switch, application goes on, application goes off. But the problem is Java applications traditionally are really not at all like light switches. You don't just casually stop and start a Java application because it takes a while to start up, or at least historically, that's how it's been. And so I think as an industry, we kind of looked and said, this isn't really good enough. Can we do better? Because this is the late 2020s, and we need to do better. And this is where Quarkus comes in. And Quarkus has really changed the performance characteristics of Java in a way that makes it much more suitable for the cloud. And so if you look at that diagram I showed earlier, you can see we have a new column here, which is that if you're running Quarkus, you're going to maybe not quite get the density of something like Go, but you're going to beat the density of Node.js, and you're certainly going to beat the density of a traditional cloud native Java stack like the one that everyone is using. And, it's a lot better. The density is significantly higher. And I should say here, when I'm talking about this kind of density, I'm talking about running Quarkus as a natively compiled binary using GraalVM. And so the GraalVM has done amazing, amazing things to make Java really able to compete with those languages like Go, while still keeping all of the Java programming models that we love. And one of the things that I think Quarkus is really good at is making sure that GraalVM is easy to use and that you really do keep those programming models that we like. If you run Quarkus on JVM, it's not going to be as absurdly tiny as Quarkus on GraalVM, as Quarkus native, but it is still going to be significantly better in terms of startup times, in terms of memory, in terms of throughput than the traditional stack. So this diagram here, it's about the density. It's about how many machine resources does this application use when it's running? How many can I fit into an application? But I mentioned that we stop and start applications on the cloud a lot. So one of the other things that Quarkus is really good at is startup time. If you run Quarkus on GraalVM, it can start a REST application in 14 milliseconds, which is ridiculously tiny. If you run it on OpenJDK, it's still 0.75 seconds. So it's not as ridiculous, but if you look at this diagram, it's about 20% of the time for your traditional stack, which is going to take 4 seconds. So you're still getting a really big win. And I want to show this just because it was one of the things that when I joined the Quarkus team, I just kept doing because it was so fun. So I have I have an application here. Oops. And if I've pre-compiled it to native, and now I run it. And you'll notice that it looked like almost nothing was happening. I just got some output, and it's because it is so ridiculously fast. So if you blink and you miss it, and blink and you miss it. I haven't compiled this to native during the course of this demo because one of the trade-offs with native is that it does take a while to compile. But you can see this is a fully functional application. So if I go to another tab, and if I do a curl, I get a response. And if I go back here and I stop it, I don't get a response. And if I go back here and I start it, then I get a response. So we've got, just this really, really incredibly fast startup time. So just for context, what I'd done there is I'd taken my Quarkus application, I just added a -p native flag when I built it, and then I get this native executable that I can launch. And once times get down beyond a certain point, it's sort of hard to really think about how fast it is. Like if that was 14 milliseconds or 30 milliseconds, would I really notice the difference? Does it matter? But I did some benchmarking against light bulbs. So we all know that fluorescent light bulbs start really slowly, but traditional LED light, or not traditional, but the LED light bulbs that we all have now, they appear to start instantaneously. But Quarkus native applications will start faster than those LED light bulbs. It is that fast. So this is cool. This is a nice party trick. But then I think the next question is, well, does it really matter? If I'm not doing serverless, does the startup time make a difference? Well, I think it does, because one of the things that we should all be going for with our applications is really trying to get that higher elasticity. And so you can, even if you're not doing serverless, if you're just doing something like auto scaling, you can be a lot more resilient to load spikes. And when the spike comes in, you can get up really quick if you do have that fast startup time. So it makes a difference. But something that arguably makes more of a difference in a lot of cases is the memory utilization of Quarkus. I showed those density graphs at the beginning. So Quarkus uses far less memory when you run it as a Java application, and it uses an absurdly tiny amount of memory if you run it with GraalVM. And I heard a lovely story about this. It was actually before I joined the Quarkus team. I was talking to someone who worked on Quarkus, and they were at a conference, and they had the team on the booth, and one of the people on the booth was one of the project managers. So not super technical. And so, as happens on a conference booth, people would come by and, he'd say, well, let me show you Quarkus, and he'd show them Quarkus, and then they'd go away. And this went on through the day. And only at the end of the day did he realize he had never actually shut any of the Quarkus instances down. And so he had been talking to lots of people, and he had 120 instances of Quarkus running on his laptop with a REST application. And the awesome thing is he didn't notice. It didn't matter at all. His laptop was not screaming. And so if you compare that to the story at the beginning, where there was this microservices application and the laptop just couldn't do it. So, for our own sort of personal convenience on our laptops, that reduced memory footprint matters. But where it really, really matters is in the cloud. Because in the cloud, in general, you're charged by your instance size. And so if you can go down to a smaller instance size because you need less memory, that matters. That translates into money. So probably a lot of you have heard some of this already, that, Quarkus has a really fast startup time and Quarkus has a tiny memory footprint. One of the things we talk about less often, and I wish we would talk about it more often, is the Quarkus throughput. Because Quarkus applications also have really, really good throughput. So we did the same benchmarks that gave those startup time and memory numbers also had some throughput measurements. And so in this experiment, we had 48 concurrent connections. With Quarkus native, we were able to handle about 3,200 requests per second. With the traditional not Quarkus stack, you could do about 3,500 requests per second. With Quarkus on JVM, it was about 6,300 requests per second. So almost double the throughput with Quarkus on JVM, which is kind of surprising because I think most of us are really familiar with these trade-offs. And so we kind of intuitively think, okay, well, if your startup time is fast, then your throughput is going to be low. But that's actually not what you see. And so this was our measurements, but we see similar experiments, that other people do. So here's one that was on social media recently. And so with Spring Boot, they had about 500 requests per second. With Quarkus, they had 3,300 requests per second, so a huge difference. And that makes a difference to the response time. So it meant that the response time with Spring Boot was almost 2 seconds, and with Quarkus, it was around 300 milliseconds. So this huge difference to the response time. And again, this is something that matters because users get really annoyed if response times are slow. And so if your application can get a better response time, that makes users happier. But I mentioned this idea of trade-offs. And so it seems like, wait a minute, this just doesn't make sense because we've got better startup, better footprint, and better throughput. But there's always a trade-off, right? Well, sort of. I think there's actually two ways that you can improve performance. One, the one that we're used to, is that you trade off one thing against another. Let me trade off throughput against startup time. But then the other thing that you can do is you can just eliminate waste, which is just a total win. So going back to these numbers, with Quarkus native and Quarkus on JVM, you kind of get the trade-off that you expect, right? That Quarkus native starts really, really fast, but the trade-off is that throughput is worse. With Quarkus against the traditional stack, there isn't that trade-off. It's actually better on all three metrics. So what's going on? How does that work? Well, I think to understand where this win comes from, you kind of need to then go back to that sort of origin of how computers used to be, which is that in 2010, say, we had multiple applications. They would all be sharing a single server instance. So you'd have, your web server or whatever, and you'd have multiple applications on that server. You'd redeploy the application many times between restarting the server. And also the application dependencies might change when it was running. So you'd have this really dynamic environment where you did everything you could to avoid rebooting the application server. And so all of the application frameworks were optimized to be totally dynamic, to allow you to change an application's dependencies, to change an application's config while it was running. But, dynamism has a cost. You pay a tax for that. And in the cloud, in containers, you would never patch your container, or at least I hope you would never patch your container, because container applications, cloud applications are immutable. When you discover something that you want to change, you just throw it out and get a new one. And if you discover another thing you want to change, you throw it out and get a new one. So the model of deployment is just completely different. But the Java runtimes that we're using are still really highly dynamic. And that is totally pointless. You are paying the tax for something that you are not using. So it's doing all of these things. It's, loading classes that aren't needed. It's doing all of this reflection that's really expensive and slow. And also, every time you start it up, it does the same initialization, even though the environment is exactly the same as the previous time it initialized. And this is in general, how Java works and how frameworks then work with Java, is that you have a very small amount of stuff that you do at build time. And then at runtime, you read a whole bunch of YAML, you read a whole bunch of XML, you do class path scanning, you then, sort of build this metal model, and then you start the thread pools and that kind of thing. But the question that the Quarkus team had was, well, what if we did more of that at build time? And you kind of have to do that if you want to work with GraalVM, but it turns out there's benefits even if you're not working with GraalVM. It just makes a lot of sense to do way more of that initialization at build time because it doesn't actually change in a container. And then you just do the bare minimum at runtime, things like starting the thread pools. And so Quarkus has this closed world assumption. It assumes you're not going to be adding things to the class path dynamically. It assumes you're not going to be changing all of this stuff with Quarkus native. It's quite a hard closed world assumption. With Quarkus on JVM, it's a softer closed world assumption. So things like reflection will just still work. It's just that you'd kind of be better off and faster if you didn't do them. And so when you move everything to build time, then that makes native compilation work, but it also makes running on the JVM better and faster. But of course, performance is important. Performance matters, but it's not all there is. For us as developers, we care a lot about the developer experience. And one of the things that I really love about Quarkus is that developers tend to use it, to love it. Once they start using it, they're like, this is amazing. And I think it comes back to when you do more upfront, you get it's like you can do things that before you would have had to do with things like aspects, and it was really sort of expensive and annoying at runtime, but now we can do it at build time and get the benefit of that code introspection. So let me show you a little bit about how it works. So let me go to code.quarkus. I'm going to choose a REST Easy application. This is called REST Easy Reactive. It's got a reactive core, but you can use blocking programming models on top of it. We're going to change the name because the name is confusing everybody and they assume that it's reactive. And of course, nobody wants to program reactive, which is why virtual threads is popular. So let's generate the application, download the zip, and open that. And then let's open that in our IDE. And we've got our Quarkus application. So let me make that a little bit bigger. So here in source, we've got, what we get a whole bunch of Docker files because we're really optimized for Docker, although static Docker files are actually not the best way of doing this because they tend to go out of date. So we prefer not to use them, but we have them there. And then you get some Java code. So we've got our simple REST application. So let's start this. So you can use Maven, you can use Gradle, or there's a Quarkus CLI. So I'm going to launch this in developer mode. And the cool thing about developer mode is that you basically you launch it once and then it will live reload from then on. So if I go back here, if I go to localhost 80, I've got my Quarkus application. Another thing that a lot of people really like with Quarkus is there's a dev UI. So I can go to my dev UI and I can see what extensions I've got. I can start my continuous testing, and then if I go back here, I can see it's run the tests. I could have also just done that on the CLI. And then I can see what extensions I've got. So with my REST Easy Reactive, it gives me a list of extensions, which is kind of useful because it also tells me what my endpoints are. So here, my endpoint is hello. So if I do localhost 8080/hello, then I've got my application. Let's make this a little bit more exciting. So let's go back here and let's put in a query param, and let's call it name. And then let's do string name. And then let's say, let's put that in. So now if I run this, I get hello null because I forgot to pass in a name. So let's pass in the name and I get, do that. Hello Fred. Oh, I forgot a space. So if I go back here and put in this space and save it, then if I run it again, got that. So that's kind of cool. But let's add in some persistence. So if I go back here and two extensions, so I'm going to add in Hibernate ORM with Panache. Panache is a layer on top of Hibernate that adds some extra usability features, and I'm going to add in Postgres as a JDBC driver. So if I do that, then let's make a new class. So I'm going to have a new Java class and I'm going to call it greeting. And I'm going to make this extend a Panache entity. And then I add my entity on it. And so this is really minimal. Panache is going to do almost all of the work here. So if I go back to my greeting resource, before I return the name, I'm going to keep track of what the name was. So I'm going to make a greeting, and let's put in the name. Well, let's make a new greeting, and then let's say my greeting name is the name that got passed in, and then let's persist the greeting. I haven't actually put in the field, so my IDE will help me out there. So now if I go back here and I run it, ooh, I forgot to add a transactional annotation here. So let's add transactional. And then if I run this, it will work. Now you'll notice one interesting thing, which is that I haven't done anything with the database. So is this actually persisting? Well, let's find out. So let's add another method. And let's call that names. Let's get rid of that. And let's call that names. And then here, let's make a list of greetings. And so I'm going to call list all. And then let's do geez. So this gives me all of the greetings that I have. Let's do a map to get the name. And then let's collect them with a comma. And then let's return oops. And I think I've got... I've got exciting syntax issues. Cool. So let's format that. So let's try that. So if I go here, and then if I do /hello/names, it's working, but I don't have any names. If I go back here and run this, then it's working and I have names. If I run this again, it's working and I have names. So what's going on? Where is this database coming from? What's happening is it's using test containers under the covers. So when we call that dev services. So it's noticed that I am trying to use a database. It's noticed that I'm in dev mode. And so it just uses test containers to start one. And we can see this if we look at my containers. I have this container now. If I kill that container and try this, then it should totally, right, let's actually kill it. And then if I go here, it's saying, hey, you're trying to use a database. You don't have one. If I want to get my database back, I can just start that. You'll notice as well that my tests were failing because I had changed my application. I hadn't changed my tests. But now if I do that, you can see I've got my database back, but it's empty. If I want to have something, because every time it sees a change, it's restarting, but it's restarting so quickly I don't notice it, but it means that my database is empty. So let's fix that. So let's add a new file, and let's have that be an import.sql. So anything in my import.sql, it will just run. So if I generate some SQL, then when I run it, that SQL is being run. If I change this and do Frank, then it will notice my import SQL has changed, and so it will recreate the database with my new import SQL. So, quick tour of Quarkus. So just to recap some of the things that were interesting there, we had that live coding with no config. It was running the tests continuously. There was the developer UI. There was the test containers where if you're not using Quarkus to integrate test containers, you have to have quite a lot of code. With Quarkus, all you have to do is not have anything. Similarly, in your config, if you configure a database, it will not use test containers. If you don't have that database configured, it will use test containers. Realistically, of course, that if you're using prod, then you probably want to have a prod profile and a normal and a dev profile so that you're not using dev test containers in prod. And we've got dev services for a whole bunch of different kinds of things. So all of the databases, Redis, Keycloak, Kafka, Elasticsearch, Kubernetes, so that you can interact with Kubernetes and it will be started in a dev service. So it's really quite powerful because you can also add your own. So I'm just going to skip ahead a little bit. When I share the slides, there is a little bit about some of the boilerplate that isn't there, but I want to just mention the last thing because I think it's really important, and then we can have a longer discussion in Q&A, which is, let's talk about the climate. Let's talk about the environment. Because Quarkus is so fast and light, we kind of suspected that Quarkus was greener, but we didn't really have the measurements to show it. And it turns out measuring carbon is kind of hard. You can measure it at the wall, but you need access to the wall. You can measure it on hardware, but you need access to the hardware in the cloud. In general, you don't have that kind of access. The beauty of the cloud is it's a black box, but you can work, if you know what instance you're using and you know your load, you can use this data set called the TEEDS data set to get carbon. And so we did that with Quarkus. We had an existing experiment where we ran an application for 20 days under quite a realistic load. And we saw that we could use a much smaller instance with Quarkus. And so then we were able to convert that into carbon metrics. And we saw that Quarkus had about half the carbon. And really, you know, there was a correlation between the carbon being lower and the cost being lower. We then went on and we did in our own lab, so we had access to the hardware. We used the hardware instrumentation, and again, we saw that Quarkus on JVM has the lowest throughput. Quarkus on native has the second lowest throughput. And if you take other frameworks, if you run them on native, that's the worst, really high carbon throughput. And even if you run them on JVM, it's actually worse than Quarkus on native. So this was something that, you know, we were really pleased to see this. And I think it does go back to those throughput numbers that I talked about. Quarkus on JVM has the lowest carbon because it has the highest throughput. So yeah, what we hear from customers and what we see in our own measurements is that with Quarkus, you could expect to cut carbon by a factor of 2 or 3. And interestingly, native, for most use cases, actually consumes more carbon than the JVM, which was surprising to us when we did the measurements the first time. And so with that, here are the slides. But I think we probably have some time for Q&A.
Yeah, Holly, thanks for your presentation. Yeah, we have some shift in time, but I think you definitely can answer for at least a couple of questions from our Slido. First of them, you already, I think, answered at least partly to this question, but what would be some disadvantages of using Quarkus compared with other solutions?
So I think there's sort of two parts to that. One is if you with native versus JVM, there's sort of a really clear set of trade-offs, right? If you're using native, then you can't use reflection. Your compile times will be longer, and you'll see probably worse throughput, but you will see this near instantaneous start. So that one's kind of easy. For Quarkus overall, it's a little bit hard for me to say because, of course, I work on the Quarkus team and we're so excited by what we're building. But what we're hearing is, in general, I think the main disadvantage is often just inertia. So we had we do a weekly stream called Quarkus Insights, and we had someone working at a French bank on Monday, and it was really interesting because he was talking about their experience shifting to Quarkus on one project. And the main disadvantage that they had actually was just persuading people. So they had to go to the leadership and say, hey, look, this Quarkus thing's really cool. And, you know, then the bank leadership went, well, it's only 4 years old. That seems really new and scary. And it was like, no, really, 4 years old. And that's quite mature now. You know, it's been going for a long time. Lots of people are using it in production. But, you know, they did have to do that, that persuasion. And the other concern that the team had, I think, was really about skills, again, of like, well, we've learned Spring, we've invested in Spring. I don't want to learn something new. And of course, I think as developers, like we should be learning things that are new all of the time, and our management should be encouraging us to learn new things. But of course, that doesn't mean that you don't want to just be in a state of constantly throwing out the skills that you have and trying to learn new things. But what they found when they switched to Quarkus was actually they picked it up really, really quickly. Like within 2 days, you know, they were kind of going full steam with Quarkus because it is microprofile. It's Jakarta. It's the familiar programming models, just with this, you know, sort of value add of developer experience around the edge.
Okay, thank you. You know, this story about only 4 years, and your example about a project manager who didn't close an applications remind me this episode from IT Crowds. I think you saw this TV show because I think
Mm.
any developer should see it definitely. When they provide for their project manager an internet, and this was like box, and she was, but why it's without any cable? They say because it's wireless. The
Yeah.
same story when you give your project manager something and didn't explain it. Yeah, it's just off top thing. And one more question with the same field. Oh, okay. I get one more question about Spring has done a lot lately to catch up on the native building of Java apps. How do you compare experience in producing native builds in Spring Boot and in Quarkus? Something like this, if I read everything correctly.
Yeah. So I again, because I work on Quarkus, I don't. In fact, I'm not sure I've ever built the native app with Spring. But what I suggest people to do is, so certainly with Quarkus, by design it's the same code base and it's just a single flag. So we really tried to make it certainly much easier than it was with vanilla Graal VM. And I'd encourage people to maybe do the performance experiments and see what they're finding the native performance like with various frameworks, because it sometimes there is quite a performance trade-off with native, and so you just need to know what problem you're solving.
Okay, and one more. You see, the idea with Octopus even was interesting for our viewers. And they say, since Quarkus is a portmanteau of Quark and us, how does the name Quarkopus sound for your octopus?
that that is the perfect name.
Yeah, I think so, guys. It was Holly and Octopus. Yeah, thanks, thanks for your presentation. Stay tuned, and we will back just in a couple of minutes. Thank you, Holly.